So we've seen the extraction process we do for fire debris, and now we're going to move in. We're in the instrument lab, and you can hear it's a little noisy in here. What that is, all these instruments in here have something called vacuum pumps, and what they do is they remove air from these systems and put them under a vacuum, so there's no air in them at all. In that process, those tools to do that are kind of loud. So bear with us as we kind of walk through here. It will be a little noisy. But now that we've taken that little vial that you saw with the carbon strip in it and added that liquid to it, now it's ready for our analysis on our instruments. And these are called GCMSs, gas chromatography mass spectrometers. The long word for it, but we all call them GCMSs too because we don't like to say the big long word every time. But what these instruments do is they separate all those chemicals in the ignitable liquids and give us a picture of what they look like. And that's what Jackie's looking at now. These instruments will run this stuff. We inject it into there, and it gives a kind of a profile or a picture that the ignitable liquid is. And each ignitable liquid is kind of unique about the picture that it looks like. And that's how we kind of compare them to known references. So we also have references over here, so we go out and collect a bunch of ignitable liquids and we run them. So we'll take a sample of these, we'll run them on the instruments, and then that gives us what those profiles look like too, those pictures of those individual products like this, like Coleman camp fuel. We'll run that, and then if we see that in a sample, in a case sample, then we can compare it to our unknown from the case to our known, and then we have a good idea of what that sample is. These things are great instruments. They do a lot of the work, but the problem is there's sometimes only a very small amount of ignitable liquid left in something that has a big background, like a bunch of chemicals in it, like a carpet sample. When carpet burns, it gives off a bunch of its own chemicals, and then it mixes with those ignitable liquids, and now we have to separate the two from there. So we're only looking for the ignitable liquid in this. And these instruments, the software does a good job of separating out the stuff we're looking for with the stuff we're not looking for, that we want to ignore, basically. So, and this is the most difficult part of the whole process, is the analyst has to sit down and actually look at the data and find a comparison, find a good reference to it, and make a decision if it meets all of our criteria. Something happens called a technical review. Is once they make their determination, they'll give it to another analyst in the lab that trained in fire debris, and they'll look it over and see if they can make the same conclusion that the original analyst did. So we always have a review of somebody else looking at it. And then from there, they write a forensic report, essentially, to the investigator saying, okay, here's what we found in your evidence. So in this case, gasoline was found in your evidence exhibit. And then that report goes to the investigator, and then they can use that to forward to the prosecutor, or if it comes up at trial or whatever else. Or if it comes back negative or something like that, there's no ignitable liquid there, then they can, maybe it's not an arson fire, that helps them kind of identify their origin and cause investigation and where to go with it from there.